Assalamu alaikum and good morning, everyone. Thank you for joining me for this exciting workshop. Today, you will be exploring the Google's AI technologies with a hands-on focus on tools like Google Colab and Gemini models. I'm Dr. Saima Hassan, and I'm a faculty member at the Kohart University of Science and Technology. Today in this notebook, I will show you how to get started with the Gemini API and walk you through some of the example prompts and techniques. So what is Colab? Google Collaboratory is a free online cloud-based Jupyter notebook environment that allows us to train our machine learning and deep learning models on CPUs, GPUs, and TPUs. It is a ready to use environment. That is, it does not matter which computer you have, what its configuration is, and how ancient it might be. You can still use Google Colab Notebook. All you need is a Google account and a web browser. Access to GPUs free of charge. And here is the cherry on top. Google Colab provides access to powerful computing resources, including GPUs like Tesla K80 and even a TPU for free. Another one is collaboration. Google Colab makes it easy to collaborate with others on projects. You can share your notebooks with others and they can edit and run your code in real time. Colab also integrates with other Google services such as Google Drive and GitHub, making it easy to share your work. So what are the prerequisite? You need a Google account to sign up. If you do not have currently a Google Colab, you can go to sign up for a free account here. When you get signed in to the Colab, you will be in this window where clicking on the new notebook, you will have access to a Google Colab notebook. So let's first talk about AI-powered features in the Colab notebook, which strengthen your development. And these features are code generation, explain error, and Gemini chat, etc. So let's continue with each of them one by one. So code generation. Open a new code cell and then click the generate link. Here is the generate. Click the generate link. This opens up a prompt where I can input what I want to code. So I want to write a Python code for a square root function. So this is my prompt, and I give it to the Gemini feature to generate this. So it has created a very simple code of the square root with proper comments for the code. This is the square root function, which is the name. So let's run this code. Okay, it has executed. Now I want to find the square root of 49. And it has given me 7, which is the correct answer. I can also create another code. Let's write. Let's generate in this prompt. Create a data frame that has midterm grades for 10 students. Then the Gemini goes and output the code for my prompt. So this is the code. Let's run this. And it will provide the midterm grades for 10 students. Now, if I want to plot this, then the AI-powered feature called recommended plots can be used. All I do is to click this button and it will show me helpful ways to visualize the data. Let's select one. Run this and it will show you the code. So these are the frequency and these are all the marks. Another feature is error explanation. Let's use the square root function, and instead of square root, if I enter an incorrect function name, so it will explain this error to me. Square root is not defined. We can click on the explain error function. And here is the Gemini chat box, which will look at this. So the Google Colab generate feature powered by AI identify and explain errors in our code, providing feedback to improve the code. If I want the Gemini to explain the code for me, it will do. Let's say enter this thing. So it provides the explanation for this code. If you have a complete program, even it will provide the explanation of all the program sentence-wise. Another feature is image analysis. You can also gain insights into an image using Google Colab AI feature. Simply provide the image link and the AI will analyze it and generate a detailed description. Let's provide this prompt to the AI-powered system. and we ask it to generate this content. So it has provided me this vibrant rainbow cake. The cake is layered with each layer showcasing this. So it has provided me the description of the image. Let's check the image. Is the description of the Gemini is correct or not? Yes. So it has provided depict a vibrant rainbow cake. The cake is layered with each layer showcasing a different color of the rainbow, creating visually appealing and colorful dessert. And yes, it is. Okay. Let's start with the Gemini API. To begin using the Gemini API, you need to acquire an API key. If you do not have, if you have not obtained one yet, you can easily create a key within Google AI Studio. In Colab, add the key to the secret manager under the key in the left panel and give it the name API key. You can see it here. It's like this. Okay, you can set up your API key like in the code. Before setting the API key, we need to install the Google generative AI. This code is to interact with the Gemini API key, and the software development kit provides a set of tools and libraries that allow us to communicate with the API and use its capability. By running this command, we ensure that we have the latest version of the Google's generative package, which is necessary for using the Gemini API. After this, we need to import some essential packages for interacting with the Gemini API key and enhancing display. So these are some of the important packages that we want to import. It's done. So now if we want to use the API key, so this code will get the API key from the secrets. If you want to use the API key within the notebook, this is another way of accessing the API key. The Gemini API provides access to a number of models from the Gemini model family, and this code will provide us all the models that are available in the Gemini model. I have run the code before, so this code lists all the models that are available within the Gemini family. If you want to search for a specific model, for example, supporting a generate content method, so we can also use this code. This code will iterate through all the available models from the GenAI list models function and checks if each model supports the generate content method. It will list all the models that support the generate content method. Similarly, if you want to search a model that support messages, so we can use this code. This code will list all the models and their supported methods. So this is the model name, and these are the some supported methods that we can use within this model. Okay, now let's run our first prompt using the Gemini model. It will test our API key, that whether it is set up correctly or not. The Gemini, we are using the Gemini 1.5 Flash model here. This is the model, and we are giving the prompt explain AI in one sentence to a kid. It will save the response in a response field and will print. So we have only given only one sentence, so it also explains in one sentence. Start a chat. So this was just a prompt, and prompt is one is the input text you provide to AI, and it generates a response. Whereas a chat-based approach involves interacting with an AI model in the form of a conversation where the system maintains the context of the interaction across multiple turns. Various applications of the chat-based approach are chatbots, customer support system, virtual assistant, and educational tools. In these all application areas, we use a chat-based approach. So So in this chat, I'm giving my name as my name, and it will respond me like, "Hello, Sama, it's nice to meet you. How can I help you today?" Now I'm asking another response from the model. I'm asking the model to tell me something interesting facts about Pakistan. It has provided the response to me. And now I'm asking again that whether the system has remembered my name or not. So yes, here it is. This is the beauty of chat-based approach. Now, if I want to print the chat history, it will provide me all the prompts and the responses that the model has provided me. Now we want to explore various parameters. Every prompt that you send to the model includes parameters that control how the model generates responses. So the first one is output length. If we can, when generating text with a large language model, the output length affects cost and performance. Generating more tokens increases computation, leading to higher energy consumption, latency, and of course, cost. To stop the model from generating tokens, we can pass a limit like this: maximum output tokens is equal to 200. We can also write in a prompt, for example, write 1,000-word essay on the important festival of Pakistan. If I do not mention the limits of the words and only provide the tokens, then it may end with an incomplete sentences. But when I'm providing a word limit, it will provide the complete response like this. So it's ended with a complete sentence. But if I do not mention the number of words and provide the limits, so it may be that the model continues generating the output, and while the token limits is complete, it will stop in the middle of the sentence. Similarly, I can give this prompt to generate. I'm not going to run this code as it just to save my tokens. Similarly, this will write a concise 50-word note on the use of generative AI in healthcare, focusing on its application in diagnostics, personalized treatment, and so on. So it will provide a response on this prompt. Another parameter is of temperature. Temperature is a parameter in language models that controls the randomness of the generated text. By adding the temperature, you can influence the creativity and diversity of the output. The optimal temperature setting will vary depending on the specific task and desired outcome. A high temperature, that is the temperature of 1, makes the output more diverse and creative, while a lower temperature, for example, 0.2, results in more deterministic and focused responses. Look at this code where I have given a temperature of 0.9, so it will create a random output. In a response, I want the model to pick a random color, and it has provided me different colors. But if I keep the temperature to 0.0, the same code has provided me a different output. This is not a diverse, but focused on one color. Okay. Zero shot. Zero shot prompts are prompts that describe the request for the model directly. This is the prompt. Classify the following text into one of the labels: dogs or cats. Text: I saw a furry animal in this. Now this model will generate a prompt, a response to this prompt. Let's see. Okay. So it has labeled it a cat. The error was because of the model that I have picked. So I corrected the model and it provided me the label cat in response. That cat is a furry animal with short tail and big eyes. So it has classified this prompt. Okay, this is the zero shot where we provided a text only, and the model has created the output based on its knowledge and information. One shot and few shot are the prompting technique that provides examples to the Gemini model and expect it to predict classes based on provided examples. When we provide multiple examples, it is a few shot, and if we provide one example, it is known as one shot prompt. So let's suppose this is a prompt where we have provided multiple examples, and the example is like the prompt and the answer. Similarly, the prompt and the answer, prompt and the answer. So there's a few short example, and now we want this text, and the model based on these examples will provide the answer. Okay. So it has classify the prompt as entertainment. You won't guess who just arrived in Bari, Italy for the movie premiere. So this is a text from an entertainment. Chain of thoughts. Chain of thoughts is a direct prompting on LLM can return answers quickly and efficiently, but they can be prone to hallucination. That is, the model has generated the answer based on its information, and sometimes the informations are incorrect in terms of factuality and reasoning. So chain of thought prompting is a technique where we instruct the model to output intermediate reasoning steps um, and provide the answers. So it typically gets better with chain of thoughts technique. So let's do an example. This is a prompt, and the model will generate the answer based on this prompt without reasoning. Now, in this prompt, we ask the model to think step by step, and it has provided the answer correctly, which is 28. But in the first prompt, it returned the answer immediately, which provide an incorrect output. The Gemini models also support multi-model prompting. So let's use the Gemini model and get this image to display. Okay. Now in the prompt, I asked the model that what is this and described it in detail. And it has described the image in detail. You can also ask the model to write a blog post on this picture, and it will create a blog post on this. So this is the code for that. These are some more prompts that you can provide to the AI powered system in the Colab, and it will generate the output accordingly. So I want the model to generate a list of cookie recipes, make the output in JSON format, and it has provided the code for this. So we can run the code, and if there are some errors, you can correct the errors as I as I have shown you that how we can get some explanation from the model. If you want the Gemini model to act as a math tutor, and you can ask about a lesson to explain it to you, you can ask. So it has generated the code for that prompt, and also when I run the code, it is complete explanation of the quadratic equation. There are a few examples. Okay, there are a few classification examples. Let in the prompt I'm giving a classification, a topic classification prompt to the model, and it will respond me that on which topic this text belongs. Classify a piece of text into this, and the text is President Biden will be visiting India in the month of March to discuss a few opportunities, and it has classified it as a politics topic. Similarly, spam detection, as we have seen in the email projects, that if there are some emails that are spam and other are the inbox, that are the email that goes in our inbox. So this is a type of spam email. Given an email, classify it as a spam or not spam email. Hi user, you have been selected as a winner of the lottery and this and that. So it will generate a response based on this email text. Okay, it has classified the mail as a spam email because this email uses classic spam tactics. You can also detect toxicity of a text, that whether in a text there are some toxicity or non-toxicity. So I have provided the text, I love sunny days, and we want to the model to detect it. Non-toxic. You can learn more on Gemini models within the Colab from this GitHub repository. There are a lot of examples in this. You can go to this Gemini cookbook, and you can find a lot more examples that you can learn. Thank you for watching. Hope you have learned from this workshop. Thank you.